So in previous videos, we've transformed relations, things like straight lines or circles, using a bit of a shortcut method. Now, first of all, I want to show you why that shortcut method doesn't work sometimes and what to do if that shortcut method's not going to work. So jumping straight into a question. So here's our question. We're going to transform y equals 2 minus 3x, which is a straight line, according to the rule this. Now I'm going to set up a bit of a matrix equation. So here's my matrix equation here. Now in the past, our next step was to multiply these two matrices together. I'll do that now. Alright, so I've done that. Now anything in pink is a bad idea, and I'm going to show you why it's a bad idea right now. Now I'm going to write those as two separate equations. So far so good. And now I need to rearrange these to make x the subject and y the subject. So I'm going to do that now. Alright, and so now they're rearranged. X is equal to x image minus 5y over 3, and y is equal to y image minus x over 2. And here is the problem. When I do it this way, I get x equal to an image of x minus 5y, the original of y. And here I get y is equal to y image minus the original of x over 2. I've got y in terms of an image and an original, and an image and an original, and that is a huge problem. So all of that working, in this particular instance where you end up in that scenario, it's not going to work. It works sometimes, but not in this case, so we're going to do something different. So I'm just going to restart the whole thing over here, and this first step in pink is really where the whole thing goes wrong. By expanding that, I get x and y all together. So what I can do instead is take this matrix and shove it over here as an inverse. Now this is useful because I'm going to be able to multiply through, once I've done the inverse, be able to multiply through, and I'm going to get x as something and I'm going to get y as something else. So I'm going to do the inverse here. So there's my inverse. I get lucky here because 1 over 6 minus 5 is just 1. So now that's just going to be 1, and I'll be able to multiply those matrices together. Now when I multiply those matrices together, I get this. 2x image minus 5y image equals x, which is an equation, and negative x image plus 3y image equals y. I'm just going to write those down as actual equations. And now I have what this failed to do. I have x and y as equations fully in terms of images, image of x and image of y. Y in terms of images, image of x and image of y. Now I can take those two equations and sub them into my original equation, y equals 2 minus 3x. So subbing in for y, I get negative x image plus 3y image, and 2 minus 3. Subbing into x, I get 2x image minus 5y image. And I can expand that, simplify. So expanding, simplifying, going one step further here, I can say y image is equal to 2 minus 5x over negative 12. That sort of negative 12 on the bottom is a bit ugly, so I can say that y image is equal to 5x minus 2 over positive 12. There is my answer. And finally, I can just rub out those little image thingies because I tried to transform y equals 2 minus 3x, and the transformed version of that is y equals 5x minus 2 over 12. Now, this version of events is necessary when your matrix has numbers in all of these columns. If you're just transforming the x by some x amount and just transforming the y by some y amount, you'll get away with sort of using this shorter version, and that's a good version to use because you don't have to deal with any inverses. This was a neat inverse, but some inverses can get really ugly. But in more complicated scenarios where the matrix is full, in case of like a lot of rotations and things like that, then you really need to go the long way around and use your inverses. Okay, that is transforming relations. It's part 3, no shortcuts. Ta-da!